Hello, my dear students, welcome to my class. Today we will learn about analog to digital conversion. That is the process of analog signal to convert to the digital signal. Starting from the very first thing, that how we can convert an analog signal to a digital signal. There are three parts of converting analog to digital signal. First is the sampling, second is quantizing, and third is coding. So why we are telling this to you, and why we are studying this analog to digital conversion process? Because in digital signal processing, you have to process digital signals. So most of our natural signals are analog signals, just like our voice signals, audio signals, and these type of signals are natural signals, and natural signals are quite continuous signal, and they are also analog signals. So whenever you want to process the digital signal, you have to convert the analog signal to digital signal, and for this you have to go through a process. So this process contains three phases. The analog to digital conversion has three phases of conversion process. First is sampling, second is quantizing, third is coding, and that's the three parts of conversion. How to convert the analog signal to digital signal. So here you can see that is the first process of conversion, or first step or first stage is sampling. So the sampling is the process of converting a signal from continuous time to discrete time, obtaining by taking samples to the signal. And second thing is quantization. It is the conversion of discrete time continuous valued signal into discrete time discrete valued signal. That means that depends on the value. And coding is the process wherein each discrete value of the quantized signal is represented by a b bit. That means the number of bits. There can be n number of bits, 3, 2, 8, any kind of 4 bit. It's a binary sequence that you have to just code the whole sequence, the whole continuous signal to digital signal. That means first of all we have to understand that what is the sampling process. So you can see that whenever an analog signal came through to the process, that analog to digital conversion. So you can see that is the analog signal that is continuous in nature, because each and every time of frame you have the value. So there is slightly any kind of gap between the values. So that is the analog signal. After passing through to the process of sampling, by sampling process, the analog signal turns into discrete signal. That's not digital, that is discrete signal, discrete. So you have to keep on your mind, that is the discrete signal. Discrete signal means it has some samples, number of samples n, and each and every type of sample it has merely get some values, that we have taken some reference values throughout the signal. How we could do it? Just think about that. Just think about that, how you could extract the values from the time frame. Okay, just look here. If we take the sample right there, and 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 the sample step size will be just 1. That means 0 from 0 to 1, then 1 to 2, 2 to 3, 3 to 4, 4 to 5, and so on. Just you are taking the sample from the total time domain. Okay, then you can find out the value between that position. Okay, how can define that this value, this value, this value, this value, this value, this value. So you're just taking the values, but just emitting the other values that is considered to be here. These type of values are neglected. Then you can just find out the usual values at 0, 1, 2, 3, 4, 5, 6, and they are called as samples. and for after sampling the value, uh, the conversion process after sampling, this type of diagrams are known as discrete signals. Discrete signals, as I have told you before, discrete. Okay, so whenever you find out the discrete signals that has the sampling rate sample, that is the V of n, that is the discrete signal, and after taking the discrete signal you have to go through the quantizing process, and after quantizing the signal will be quantized signal. So what is the quantized signal means? So there are some value in that you have taken in the previous section. The value, that means that is the value, that is the type of value that each and every sample has a value in the y-axis. That means this existing signal has some values with reference to or with regard to its x-axis, or you can say you are taking the value of samples right there. After taking the value, you got the quantized signal. What are the quantized signal? Here you can see these are the signals of the quantized signal. That means you have to value through to the y-axis now. So that is the quantization process. First of all, you didn't know the value. First of all, you didn't know the value through that. First of all, after sampling, you just taking the value from the x-axis and just take the reference value from there. And if you want to just in quantization process, that you have to slice from the y-axis, that is the graph through the y-axis, and get each and every value from there. Here you can see this value, that has a value from in the y-axis, in that point of tip point, that is a value, in that point of tip point it has a value, in that point tip point it has also a value. So in general, if it is a continuous signal, after sampling you just get these points, this reference point out of that, this reference point out of that, then just remove some important parts, that just remove the parts from there, just remove the part from there. Okay, so that is the thing. And after removing the part, you just get this type of signals. It is the sample, it has the point there. It is a sample, you have got the point there. It has a sample, you have got the point there. But it has not specified any kind of value. So how you could specify it? Now you have to take it from the y-axis. You have to look forward from the y-axis. Now if that is a sampled signal, as you can see, so after putting the value from the y-axis, we get this one. From the y-axis, this point is considered to be 3, I guess. This is considered to be 2, I guess, and this again constitute 1. From which point of view? From the point of view of y-axis. We just take the value from y-axis. Okay, so that is the quantized signal in broader context. After taking the quantized signal, just taking the value from the y-axis, that means from this axis reference, and you have the value from the quantized signal, then you have to do the coding section. Coding section means you have to convert these values. These things to that is 4, that's the value of the y-axis. You have taken the value and you have just represented the value with binary digits, just b-bit binary digits. Just coding just means just convert these type of decimal figures or any kind of data to binary or digital data. So that is the coding process. That means to convert quantized signal to a digital data is known as coding process. So the 3 processes combinedly called the analog to digital conversion process. Thanks for being with me in that part of lecture.